Welcome back to the channel. Hope everybody's doing well. And today we're on with our HT8051 Process Calibrator. Now these instruments are specialist instruments. They do have very limited functionality, but they do that functionality very well and very accurately. Now this particular instrument can either supply or measure 0 to 10 volts, or it can supply or measure 0 to 24 milliamps. In terms of accuracy, on all the ranges that it has is 0.02% plus 4 digits. As a comparison, the U1282A multimeter I have from Keysight, on its 6 milliamp range, that can do 0.05% plus 5 digits. On the 60 milliamp range, that is 0.1% plus 20 digits. So quite a bit less accurate than the HT8051. In terms of voltage, up to 10 volts I would have to go up to the 60 volt range, so that would be 0.025% plus 5 digits. But it also does that in the 6 volt range as well, and the 600 millivolt range. So you could use that in place of this for the voltage function, but you couldn't use it to check out the functionality of this. And even if I look at my big Fluke 8846A that is currently in bits trying to be repaired, in terms of the amps, on the 10 milliamp and the 100 milliamp range, you have 0.05%, but you have plus or minus 0.2% of the range for the 10 milliamp and plus or minus 0.005% on the 100 milliamp range. So even that can't match the current capabilities of the HT8051. In terms of voltage, the 10 volt range, it can do 0.0024%. Plus or minus 0.0005% of the range. So in that respect, it can outperform the HT8051. And that's at its 1 year calibrations. Even on its 90-day calibrations, the current still can't outperform the HT8051. And that's why we've got the instruments set out there to the right. These are both Keithley instruments. The DMM7510 is a 7.5 digit multimeter, and the 2450 is a source meter. Can provide the current and voltage to check it with. So the DMM7510 on the 10 volt range, we are 14 ppm plus minus 1.2 ppm. On the 10 milliamp range, we are 100 ppm plus minus 15 ppm. So it's just about better than the HT8051, but for calibration it's still looking a bit dodgy. On the 100 milliamp range, unfortunately it creeps up to 400 ppm plus minus 30 ppm of the range, so that's less accurate than the HT8051. Now I do actually keep an independent UCAS calibration on both these instruments, so I know they are actually more accurate than that, so I can get a good idea of how well this instrument is operating by using these instruments. And you see at this moment in time we are demonstrating current measurement on the HT8051. We're injecting 4.0002 milliamps, which is being read as 4.0006 on DMM7510 and 3.998 on the HT8051. And we'll go up to 8 milliamps and see how we do. So a fast response from it, but 7.996, again a little bit low in comparison to the 8.0009 displayed on the bench meter there. Let's go 12 milliamp. So we've had to go up a range now, and we're on 12.001, which matches across both instruments, but we're on 11.994, displaying 49.9%. Let's go to 16, which is 15.99. Dead 16.000. So you can see the instrument appears to be reading slightly lower than both of these instruments. 2.988 in comparison to 20.001 at the full 20 milliamp loop current there. So I'll just knock that off and we'll reset everything to measure voltage. Okay, so we're back with the instruments and we are measuring 0 to 10 volts on the HT8051 now, and we are supplying dead on 10 volts, but our DMM7510 is reading 0.002 9999, which actually correlates with the HT8051 there. So we'll take this up to 2.5 volts, 2.498, 2.499, 5, 4.996 against the 5.0001. Let's go 7.5, 7.499 against 7.495. And finally, full range is 10 volts, 0.994 next 0.999. Okay, so next range on this is the 0 to 100 millivolt measurement. So let's go down to 5 millivolts, I think. And you can see right at the bottom scale on the voltage on there, but if I hit the mode button, we're into millivolts. And we can get 4.97 against 4.98 on the DMM7510. Let's go 10 millivolts. 9.97, it's 9.98. Oops, 25 millivolts. 24.98, 24.99. So pretty respectable, really. 50, 40.98, yeah, 75 millivolts, 74.97, it's 74.988, and for 100 millivolts, 99.97 against 99.98. Okay, so that's the measurement capabilities shown you there. Just have a quick change around and we'll move this on to voltage and current simulation. Okay, so we've reconfigured and we've now set up to source milliamps out of the HT8051, and we just have the DMM in circuit here reading the current being generated at this moment in time. Once you've switched the meter from a measurement mode into a source mode, these other 3 buttons that you see here can now be utilised along with the rotary encoder just at the bottom of the picture here. The first button is 0 to 100%, just switches between the two. So we're on 0, which is 4 milliamp. I press it, it goes straight up to 20 milliamp, which is 100%. Press it again, it takes you back down to 0%. Next button is a dual function button. Pressing of this will take it up in 25% steps, all the way up to 100%, and then when you reach 100%, it takes it back down in 25% steps. And if you hold this button in for more than a couple of seconds, it will actually bring on the backlight. I'll try and demonstrate that later on because the backlight is really, really poor and you just cannot see it in this light. I'll hold it in and there is no chance. I can't even see it myself. I can't even see that the backlight has come on underneath, so we'll take a look at that towards the end of the video. This next button down here is for ramp modes, and this has 3 different ramps available. The top one here, the stepped one here, will take it from 0 to 100% and again back down to 0 in 25% steps every 5 seconds. The second one, which is the large triangle, is a slow linear ramp which is 0 to 100% and back down to 0% in 40 seconds. And then the very bottom one here is a fast linear ramp, which again 0 to 100% back down to 0 again in 15 seconds. The issue that I found with this is it looks like it will go to step ramp first. So when I press this, it's actually gone up to the second one, which is the slow ramp. Press it again, I'm now on the quick ramp, and you can see it really goes up in a 1 micro resolution. It just continually cycles, and then when I press this, you can see it's moved to the 25% step, and unfortunately you have to wait for it to get off that first step, and then it will correct itself and go to a standard 25% step mark. And so now on the 50, on 75, up to 100, and then it'll start going back down again. But if I change it to another ramp and then go back to the step one again, it's just sheer luck where it actually ends up. That first ramp function seems a little bit untidy to me, as opposed to the other two. Outside of that, if we just keep it onto the, we'll leave it on 8 milliamps with the rotary encoder here, I can actually dial in a value I would like. So there's change it at whatever digit you want. If you press it, and it moves the little indicator there onto the next digit, and then you can change that one. Press it again, and you can change that one, and so on. So you can dial in whatever value you would actually like. So that's the basic operation of the meter. What I'll do now is use the 25% button just to step this through the range of the output for some accuracy checks at the 4 points here. So we're on 4 milliamps, so you can see we've got 4.0026-ish, 32, yeah, oscillating a little bit on those last 4 digits. Let's go to 8 milliamps, that's that one there, 12 milliamps, 16 milliamps, 16.01, starting to get a little bit out now, 20 milliamps, 20.0137-ish. 381 again, those last 2 digits oscillating around a little bit. Okay, so that's the accuracy on that one done. We'll just change mode and we'll change over to voltage. And we need to go, and there we are on output volts there. So again we're on 0%. And then we need to change our connections at the top here as well. That's one disadvantage to this instrument. There's quite a bit of changing around of connections. We are on 0 and showing 1.16 millivolts. So what we'll just do is change this up to 1 volt. And then we'll use our 25% button. Like that, did it? Yes, 25% just adds on. So let's just take them down to 2.5 volts there. And then press them again. Why have we got zeros? That didn't work, did it? Must have changed the direction when I took it from 3.5 down to 2.5. So we've done that one. 5. Another percentage, 7.5. And then final max 100% is 10 volts. Okay, so that's the voltage output. Another press of the mode button takes me to millivolts output. Again, we've started at that's 1 millivolt there. And let's take it back down. Let's take it to 10 millivolts then. And then I'm just taking it back down again so the 25% works. So that should 25 millivolts now. And then 50 millivolts. And then 75 millivolts. And finally 100 millivolts. Seems pretty accurate. Again, there is a bit of movement on these last few digits on the Keithley there. What I'll do is I'll put them into some Excel tables along with the previous results for the actual measurement function, and we'll see how they pan out against the actual tolerance specified in the manual. So here's the 2 tables. The one on the left is for when the HT8051 is in measurement mode, and on the right it's in source mode. So if we start off looking at the milliamp readings at the top on both of those tables, you can see on both measurement and source, as the instrument gets towards the upper levels of its range, they start to creep out of tolerance, not by much, but from measurements I made, they are a little bit out. Millivolt wise, there is one reading that's ever so slightly out for source mode at 50 millivolts. And so that could be a discrepancy in the measurement method when you get the oddball reading like that. In voltage terms, at the bottom of the tables there, they all look to be okay, all within tolerance. So that's the measurements that I made there. I don't have anything to compare this to. Strangely enough, this instrument does not come with a calibration certificate, unlike the two multimeters that I've purchased from them, the HT65 and the Neptune. They both come with manufacturer's calibration certification. The HT8051 doesn't come with one at all, which I find slightly strange, because if there's one instrument I would want to have a calibration on, or I would regard as being more important to have a calibration on, would be something like this Process Calibrator, as opposed to a standard digital multimeter. So we'll move on now and take a quick look at this backlight that I don't think much to. Okay, so we've dimmed everything down in the hope that I can display this backlight to you. If you remember, it's the 25% button that you hold in, although you probably can't see that right now. But there you see the backlight has just come on. It is showing a little bit better to me myself. It's still dimmed down a little bit on the camera, but it really is a very poor backlight. I've tried holding the button in, it doesn't increase the intensity of it at all, so I'm not sure really why it is so poor. You've just seen it gone out there. If you look at their other instruments, they do have really good backlights on them. It just doesn't seem to have been carried over to the HT8051 there. So the backlight is also the indicator for that the unit is on charge. This has an internal PP3 9-volt battery on it. You can connect this charger that comes with the instrument in at two terminals at the top, and then when you plug it in, you can see the screen has lit up, and that's the indicator to say that it's on charge. But you can see it's actually lit up and it's got more intensity than when you're using it as a backlight to display the readings. So yeah, it's a bit of a strange one, this backlight. I'll plug it and hopefully you can see it flashes and then goes off again. So just before we bring the video to a close, just go through the meter itself. As you can see, it comes in this kind of flight case arrangement. This was the holder for the battery that it came with. Pocket at the front here, you've got the leads, two leads with it that come with probes attached to them, and then crop clip for each one. To my mind, given that this is for actual transducers and fairly small wiring systems, I would find these crop clips a little bit too big really, and the probes as well. For getting into terminals, they're probably going to be too big as well. I would probably favour for work on transducers and clipping onto those, this style of crocodile clip, much smaller, will get much better grip on the wiring than these two will. And as I said, you've got the charger here, fits in this pocket here, and then the meter fits in the pocket at the back. And that's all you get with the kit, along with the instruction manual, of course, which is in multiple languages. Okay, so in fairness, the manual is pretty good and explains itself. It's got diagrams for each test method that you use the instrument for, and all the specs and everything, so that's pretty reasonable manual there. The meter itself, it's fairly sizable instrument. If I bring my U1282 there in picture as well, you can see it's about 3/4 of an inch taller than this instrument, similar sort of width and depth to it as the key sight there, just that little bit taller. Tilt bail at the back, it is serialised here. Battery compartment is in there, so you can get into that and replace the battery either with a standard 9 volts or the 7.2 volt rechargeable battery. And at the front here, the instrument itself is in this little boot. The boot doesn't seem to fit too well really. It seems to stretch quite easy and then not go back into position. But it's provides it with a little bit of protection, I guess. All the connections to the instrument are at the top here. I do find that a bit difficult to read in poor light. Again, if you've got good bright light like I have here, it's not too bad, but in poor light that is a bit hard to read as well. And you couple that with operation of the backlight and the kind of leads that it comes with, I feel that there are a few things that could be done better with the instrument. But that'll be it for this video. Thanks for watching. I hope you found it useful, and I'll see you again in the next one.